Hey Rory.
Hi everyone. I'm guessing that I'm live. Just tell me when I can start, and we're going to do 30 minutes, and I'm going to teach you microservices.
Awesome. So how are you doing, Rory?
Yeah, it's nice. This climate is different, the COVID climate, and here at Microsoft, we are empowering developers in every organization to do more, and one of those is with Java. So my colleague Sandra did an incredible talk on Azure functions, and I'm going to show you how to take that Azure function into a microservice, and in 30 minutes, you're going to know how to do microservices.
That would be awesome, Rory. So shall I put your screen on stream?
Yes, please.
Sure. So Rory, going further, you can give a quick intro about yourself, what you're doing, and what this session going to be about. So I hope you will be giving a demo on that.
Yes, I am, a live demo. Hopefully it'll work. You'll see here, I'm going to spin up a Kubernetes cluster, Spring Azure Cloud cluster. So a lot of moving parts, and let's see how that goes.
Awesome. So here you go, Rory.
Great. So hi everyone, my name is Rory, and I work in the developer relations team at Microsoft as a senior cloud advocate with Java. You've already met my colleague Sandra, and we empower organizations around the world to be able to use the Azure platform to achieve more. So let's set the stage. So Spring's flexible libraries are trusted by developers over the world. And you can see here from the latest SNCC report that a significant number, 50%, indicated that Spring Boot is their framework of choice. I guess most of you are actually using dozens, if not hundreds, of microservices and Spring Boot applications in production today. However, business is growing, technology is evolving, and distributed teams are changing. Companies are looking to become more agile so they can innovate and respond to change faster. And we've seen now with this COVID climate that remote development, remote distributed teams is the new norm. In large distributed projects, we firstly need to let each team independently build, verify, deploy, and monitor their services. Applications need to scale quickly to potentially millions of users around the globe. We need independent services that can be scaled based on their respective demands. We will also need more efficiency through end-to-end development experience, coding, debugging, deployment, monitoring, and management with integrated tools and DevOps. And finally, then we have a chance to achieve reliability and faster time to market. To achieve these goals, today I'm going to be explaining how to build your services independently and run them globally. We'll see how you can scale your services and manage the app's lifecycle efficiently. And then we'll discuss how to deliver these values faster. Microservices are a software architecture style in which applications are composed of small, independent modules that communicate with each other over well-defined API contracts. Each service is a highly coupled building block that is small enough to implement a single functionality. A typical microservice architecture consists of a collection of many of these small autonomous services. Besides for the services themselves, other components appear in a typical microservice architecture. First of all, we have management and orchestration. These components are responsible for placing services on nodes, identifying failures, rebalancing services across nodes, and so forth. We then have an API gateway. As you can see from the diagram, we have many microservices which expose external APIs to clients. In real-world systems, this number can grow very quickly, as well as the entire system's complexity. Usually, a much better approach is to use an API gateway. We've discussed the building services independently. Next, how can you actually run these applications globally? It's quite easy to get most of the value out of the cloud. You can use the many data centers that Azure has in different regions worldwide. Now, I've got a plan. I'm going to show you how to build cloud-native microservices, and 2, leverage off the Azure Global Data Center footprint. Part 1 can seem difficult. I have dozens of microservices. How do I design them for the cloud? So let's start. To achieve this, we're going to use Spring Cloud as our platform. Spring Cloud provides 4 key services necessary for our microservices. A Spring Cloud service registry can help by enabling client-side load balancing that decouples our services from its consumers without the need for a DNS. Next, we have Spring Cloud Config, and this is designed to ease the burdens and off integration with versioning control systems like Git. Next, we have Spring Cloud Sleuth, and that instruments my application in a predictable and repeatable way and gives me access to see the logs for my distributed application. And finally, we have Spring Cloud Gateway, which gives me precise control over your API layer, integrating Spring Cloud service discovery and client-side load balancing solutions to simplify configuration and maintenance. In short, Spring Cloud can help me, as well as you, build cloud-native microservices easily. So let's see how we can take this configuration and connect it to the many back-end auxiliary systems that you have in your typical environment. There's actually an easy way to seamlessly integrate with these rich assortment of managed back-end services. Instead of owning the service, you simply consume it. And if I want to use them, but I don't want to add them with a lot of Azure-specific code, you can achieve this by using Spring on Azure starters. These are open source libraries that further simplify connection and consumption of Azure managed backing services under the Spring framework. They give developers a Spring idiomatic way to connect and consume Azure services with only a few lines of configuration and really minimal code config. Next, we have our ecosystem. In this ecosystem, you can find so many different Spring offerings: Spring Cloud, Spring Data, Spring Relational, RTDBC, Spring Security, Cache, Resources Messaging, and Micrometer projects. Let me share 2 examples here. So, and these are your Spring integration starters. Azure Cosmos Db is a globally distributed database that Sandra just demoed that allows developers to work with data in a variety of standard APIs: SQL, Mongo, Graph, Table APIs. The Spring Boot starter for Azure enables developers to use Spring Boot applications and easily integrate with Cosmos DB by using different APIs within a Spring idiomatic way. Next, we have Spring Key Vault, which can be used to easily store and lightly control access to tokens, passwords, certificates, APIs, keys, and other secrets. And you can see from this ecosystem here, we provide Spring integration libraries in an idiomatic way for nearly all of those ecosystem requirements. Great. So we've decoupled our application with microservices. How do you scale them based on their respective demands without impacting the overall performance? We've already introduced the concept of orchestration earlier. Typically, this component is an off-the-shelf technology such as Kubernetes. Kubernetes orchestrates clusters of virtual machines and schedules containers to run on them based on the resource requirements of each container. It is the platform I'm looking for to really manage and scale my microservices autonomously. And this is the platform that we're going to focus on for the rest of the talk. This is a workflow that you see in this diagram to illustrate how Kubernetes rolls out work. But it seems I need to understand a lot of moving parts like pods, schedulers, YAML, and how to open different services. It's not an easy job to manage Kubernetes by myself. Besides Kubernetes management, how do I take care of the end-to-end application lifecycle from deployment, scaling, and monitoring? As you know, the most challenging part for an ops part of microservices is the whole system, including Kubernetes, JVMs, Tomcat, Spring, and keeping the business continuity going. So introducing Azure Spring Cloud. So Azure Spring Cloud is a fully managed platform as a service, and it takes care of the patching. It also offers custom domain data encryption and other capabilities for enterprise-grade capabilities, it takes the headache out of Kubernetes. To manage the life cycle, more things I need to do on my daily work. We have dozens of microservices, CI and CD pipeline, and automation. And we have to have these to be able to really fulfill that enterprise contract. Azure Spring Cloud offers me these in an Azure CLI, PowerShell, ARM template to automate the resource provisioning. It also offers Azure DevOps in GitHub Actions and Jenkins, as these are the most popular tools. You can see here from the diagram, it has a lot of other integration features here that allow me to really take the hassle and the headache away from Kubernetes management. We also have the ability to tie into the build service, the Azure Spring Cloud build service. And let's have a look at exactly how we can manage to do that via the connection of our CI/CD and our automation platforms. We'll also look at how to do distributed tracing with Azure Monitor, and then finally also look at integrating with Azure Active Directory. So besides CI/CD pipelines, Microsoft also has partnered with Pivotal to bring you Maven and IntelliJ plugins to deploy your applications to Azure Spring Cloud in a few clicks. It supports both FatJar and source code, and it has built-in VM Tanzu build service that uses cloud-native Bullpecs to build container images. We're going to do that in the demo from source code. So let me just show you a brief introduction of how to actually use that VMware Tanzu build service. So here's cloud-native Bullpecs, and this was introduced in Spring 2.3. And what it does, it actually analyzes your project and creates a custom Docker image based on some AI algorithms that would make your image really shine in cloud native. So we're creating from our service, our microservice, into a cloud native platform that allows us to really go and deploy this into our Azure Spring Cloud cluster. Now, what I didn't tell you is that Azure Spring Cloud actually runs on top of Kubernetes, and it obfuscates that requirement to understand Kubernetes. And we're going to do that a little bit in the demo. Then I'm going to show you how to create your cloud native build pack. So as you can see also from this distributed tracing, we've given you also out-of-the-box support for integrating logs, metrics, and distributed app traces into Azure Monitor. So you can easily visualize how applications are performing. In the demo, I'm going to show you how to do that. I'm going to create a bug, and then we're going to try and find that bug via distributed tracing. You can also isolate potential problems to individual services. Furthermore, I can set alert rules that are important conditions like request counts, CPU usage, and then I can identify and address issues before users notice them. So let's see how to support multiple teams that work on different services at the same time and put these features into production. This is the final part of the presentation, and then we're going to do the demo. So Azure Spring Cloud leverages the power of Kubernetes. It runs on top of Kubernetes using as cloud-native build packs to orchestrate your microservices. It abstracts away the complexity of infrastructure management and offers pre-configured Spring Cloud components and ready-to-deploy environments. So your teams can focus more on building business logic for each service independently in parallel, and let Azure take care of the rest, such as dynamic scaling, security patches, compliance standards, monitoring, and high availability. The good news also, it's jointly built, operated, and supported by Microsoft and VMware. And that is Spring Cloud running on Azure, backed by Kubernetes using cloud-native build packs. And it's a lot to take in, but I'm going to show you the simple demo that I've got that is going to allow us to take that next step in building your services. And I'm going to come to my PC, and the demo is pretty simple. I'm going to create a to-do application. It's going to use build packs to build a cloud-native image, deploy it to Kubernetes, and then I'm going to show you the same process using Azure Spring Cloud, so you understand what it does in the background. And then I'm going to demo distributed tracing, the registry, API gateway, and I'm going to do blue-green deployment to fix the bug that I'm going to show you that I have. So I'm going to get out of my slides, and this is always kind of scary when you get out of the slides. You don't want everyone to see your PowerPoint presentation. And then I've got my terminal. I've got Visual Studio Code. I'm going to make it a little bit bigger. Is this the nice size? I know that the StreamYard might be a little bit too small. This is a nice size here. Now, kind of set up my application beforehand, and the easiest way to set that up, I'm going to go into Chrome, is I've preset up, where is my Chrome? Actually, I can just open up a new window. It's the nice thing about scripting everything else. So I'm going to initialize. I'm going to show you how to initialize your application. There's my Chrome. There we go. New window. Here we are, Chrome. I'm going to make that a little bit bigger. Options. We want to go zoom. And let's make that bigger. Plus, 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 plus. Cool. Now you can go to start.spring.io, and I've already kind of initialized that. And then I've set it up that I get and for this demo, we're going to use an H2 database, Spring Reactive Web, and Spring Reactive R2 DBC to connect to our reactive database, and then create a RESTful services using the reactive paradigm. Then you just go generate, and it's going to copy a zip file, which I've already kind of set up. And then in that zip file, then you're going to get a config like this, where you're going to have your source folders and an empty application of properties. And then you're going to have a POM file here with all of your properties here. So we're gonna just delete all of that, and I'm going to show you how to actually create it. So first thing I want to clean that up a little bit, because I want to create 2 profiles to run in the cloud and run locally. So I've set everything up beforehand, and I've got my POM here. Let's just go through that briefly. And I've got my coordinates. I've got I'm going to use 1.8, Java 1.8, Azure Cloud 2.3.1. And then I've got my dependencies. I'm going to use RTDBC, Webflux. I've got my H2 runtimes. I've got JUnit. And then I've also got my dependency management for my versioning. And then I've got some also dependency management. And I've got a cloud platform. So when I want to run it locally, I don't want to bring in all my dependencies here. And the cloud platform is pretty simple. I've got cloud config, Sleuth for distributed tracing, Zipkin also, Eureka to manage the registry. And then finally, also, I've got the cloud starter, which really kind of lets me connect to my Eureka client. So that's my POM done. Let's create our reactive to do microservices. And I've already kind of scaffolded out the empty classes here. I've got my application, I've got my to-do class, I've got my controller, I've got my exception if I can't find it, and then my repository. So we're going to create our little to-do here. And with the power of snippets, I'm going to show you how to do that live coding, semi-live coding. And I'm going to go JCloud, and I've got to-do here. And the to-do application here, the DTO, just has an ID, a title, completed, and it binds really to the table to-do. Pretty simple. Then afterwards, I've got my to-do repository. I want to pull those to-do items out of my to-do repository, and I can do that with the power of semi-live coding, and I can go repo. And this is a pretty simple repository here, and it just goes public interface repository, extends reactive CRUD repository. I've got one little method I've added here, find by title, which just says select star from to-do where title equals to title. And that's how you do reactive repositories. It's as simple as that. Once I have that, I want my not found exception. So I go JCloud, and I must actually keep times on the time here. JCloud exception. So now if I can't find it, I can actually create my to-do not found exception. Then I want to actually create my controller and my RESTful services. I'm going to create my controller. And this controller is pretty simple. It has, and I've hacked it, and this is the bug that I'm going to introduce, cross-origin, and I'm just allowing anything there. This is a really big security risk, though, to allow everything. I've got my request controller that injects my repository, and then I've got some methods here, get all, get by ID, add to do, update, you know, your general, your CRUD actions. And then finally, I want to do my main method here, and I want to create my, no, there we go, a JCloud app. My main method here really kind of shows you what we're going to do. The first thing it's going to do is going to create the table if it doesn't exist. And this is just a Spring Cloud application here that runs the command line runner. It's going to create the table if it doesn't exist. It's going to delete and refresh it so we can start again. It's going to create a stream of objects that I'm going to insert here, of to-dos. I'm going to save them all. And remember, every time that you use reactive, you have to block or subscribe. So I'm going to subscribe there. And you can actually mouse over there and you can see how to use reactive systems there. Then I'm going to use find all. I'm going to find them, find by one, find by title, and then that's everything that I'm going to need in my application. So this should all run. And the nice thing about Git is that I can actually check if I've added anything or removed everything. So let's just go make sure. Yeah, that's fine. The POM, that's fine. So let's run that now that I'm happy with the application. And I just run this, and I'm running this locally without any cloud engagement. I can just go run and debug. If the demo gods are great, then it should. And it's going to connect to my database. It's going to insert my to-dos. And then it's going to create my RESTful services. And it was quick because it's an H2 database. So now you should see my my RESTful services here. And I can go to a localhost 8080, and voila, I have my to-dos. It's as simple as that. I created a reactive application. Now let's go and create a cloud native Bullpec of that same application. So now I've got my little terminal here. And the first thing I want to do is I want to get my install my my cloud native Bullpecs, and you can, I've already installed it, but to do this on a Macintosh, you just go paste brew install Bullpecs and tap Bullpec. It's pretty easy. And then I've got the ability to run pack, and I'm going to now take my application and I'm going to build it into a cloud native Bullpec. And you'll see here, I'm just going to paste that in here. I'm going to go pack builder, and I'm going to use the Alpine builder, Alpine Linux. I'm going to call this Rory Pretty Spring Cloud and pop it into Docker Hub, and I'm going to make it verbose so you can actually see how that's working. And so this is going to create my Docker image locally and also in my my Docker Hub repo, and I'm going to push this into my Kubernetes cluster. It's as simple as that. Now you can see here, it's going to analyze my project, and it's going to say, wow, okay, cool. These are the libraries I'm going to use to analyze it. It's got Java, Kotlin, and all of these things. It's pulling them array, and luckily I've already got the layers done there, so it shouldn't take too long. Detecting, it's going to find out what the layers are, and it really did that there. It's detecting Java, and it's detecting Maven. You can see there, Java pullback, installing JDK, building Maven, and adding the different layers onto my Bullpec, my cache layer. You can see there it's adding the Java, Maven, the JDK, the actual application that I'm going to run, and it's done. I've just built a cloud native Bullpec with all of those images, and I can go Docker images, and I can find that image. So Docker images, and if I can find it, Docker images, inspect. And we want to go Rory Pretty and / going a little bit off script here, Spring Cloud. You can go and inspect those. Yeah, it doesn't like the inspect. Let's just go Docker images. Let's go Docker images there. And you can go inspect it, and you can see all the different layers. And then I've got my layer there. Now I'm going to push that to Docker Hub. And you can push this to your ACR registry, your Azure Container Registry also. But I just find that it's simpler if I just go Docker push, and then I've got my Spring Cloud registry. Just want to make sure that I'm on time. Let's go into PowerPoint. Well, I can't actually see the time. Where's the time here? Yeah, I'm still really much in time. And it's going to pull those actual layers down, and then I'm going to push this to my container registry and run a Kubernetes cluster from this. Yes, I know, I am brave to actually do that. So I've pushed it to my registry. I've already logged into my Kubernetes cluster, and you can see that by going into Docker, and you can see Kubernetes I've activated, and I've already created a Kubernetes cluster. And I did that with the DevOps starter. You just go into Azure DevOps starters, go create a Kubernetes cluster, and I'm just using that off there. So I've set my account already. Now I'm going to go and I'm going to delete everything. This is really brave. kubectl. I'm going to make sure that everything's clean. Delete deployments. and dash all. I'm going to delete everything there, and then I'm going to go kubectl delete services. Yeah, okay, it had it running, and then I'm going to go delete services. This is so brave. Services dash all. There's nothing running on my Kubernetes cluster. And this is running in Azure right now. So kubectl get all. You can see that there's absolutely nothing running on my Kubernetes cluster, no resources. So then I'm going to create my deployment in my Kubernetes cluster from that image in Docker Hub. And I'm going to go kubectl create deployment demo. We're going to call it demo. And then I'm going to use the image that we just created, Rory Pretty Spring Cloud. Done. So this will actually do that. It will take a few seconds actually. And then I can go kubectl get all. And it should actually show me that my deployment is created. Great, it's saying container created there, and we can wait for that to get created. Hopefully it does create. Container created, creating. While this is working, container creating, we're actually going to go create our services there. So I'm going to go kubectl create service, and I'm going to give it a cluster IP because I want to really expose that to the world internet. And then I'm going to say demo and bind to port 8080 and have the external port 8080. So that's going to create my service. Demo created, that's great. So I can go kubectl get all. This is so brave. Sandra, if you're watching this, just understand that this was really well rehearsed before I actually did it. And it's got the Kubernetes cluster, and it's busy creating that container. Remember, this is inside Kubernetes. And then finally, also, I'm going to actually go in and create my port forwarding and bind to that port. And hopefully it will be ready by then. Else we can start the next part of the demo and come back to that. So I've got port forwarding and my services, port 8080. It's going to randomize, unable to forward the port because the port is not running. Okay, so let's give it a few seconds and then let's wait for it to actually run. Let's see here. Get all. Container creating. Let me just make sure I'm in the right subscription also. Should be in the right subscription. Paste. Yeah, that should be that. Okay, well, once this is running, let's go back and actually see how to do this now, this entire process with Azure Spring Cloud. And you're thinking, you know, there must be so many different actual steps. So let's wait for our cluster to come back and let's go do this in Azure Spring Cloud. Now, I've already created my Azure Spring Cloud. So if I go to my portal, I've created my Azure Spring Cloud. And it's pretty simple to go in and check your Azure Spring Cloud config. And I'm using a pretty simple configuration. And I've got my to-do application. I've also got a, let's find it there, Spring, and I called it Spring 1 demo because I'm doing Spring 1 soon. Spring 1 demo, and I've got my apps that I've already created, and I've got my to-do app ready for me and waiting for me to config. And then I've also got my gateway. So this was just a cloud gateway that we've that I've deployed before, and I can go into my terminal now, and I can run the command that we can actually go in and run the exact same services, cloud native and Kubernetes cluster creation. And it's as simple as that. All I'm going to do is just run this command, and we can go through the command, paste. I'm going to go AZ, which is your Azure command, Spring Cloud app deploy to do, and that's the actual name of the Spring Cloud group. Resource group, I've already given the resource group, the jar that we've created from the project, and done. It's going to take about a few minutes to run, so could not be found. Oh, I need to log into my other resource group there. Yeah, let's go there, and we want to log in to our different subscription because we didn't have that. So I'm going to log in, set the account to that subscription. So this is what happens when you run in multiple subscriptions. You kind of lose track of where you are. So let's actually go into that subscription. And I want to go and I'm going to set my subscription. This is also a nice way to show you how many subscriptions advocates have. Let's go set that. Okay, got my subscription, and now I'm going to actually do the same command there. And now it's going to actually take a few minutes to run. And we, while that's happening, we can actually go in and see our Kubernetes cluster if everything according to the demo ran accordingly. So I'm going to create a new terminal here, new window. Let's make that a little bit bigger. And let's actually go kubectl. Let's go into the different I'm going to go into my different subscription. I'm using 2 subscriptions at the same time. Set the subscription, and then it should actually create. All the demo gods didn't shine too brightly on me. Get all. It's still creating the container. There must be an issue with it, but it doesn't matter. I'll show you how the demo actually works. But it also shows you how difficult it is to actually create Kubernetes on the fly, though. I don't know why the Kubernetes cluster didn't work, and for me to go in and find out those that log would be really difficult. Whereas with Azure Spring Cloud, it does all of that for me, and it creates the cluster for me with that image that I created from the jar file with those cloud native Bullpecs. Now, I can actually go in and show you how this looks. Let's go in there, because I've got a blue-green deployment. So in my apps, in my to-do application, I've got 2 apps. One is you can see here, let's go to deployments. Let's make that a little bit bigger. Let's hide that. How am I doing for time? Should be still plenty of time. So I've got my to-do application here, and I've got, let's go bigger. Plus, there. So I've got my to-do application here, and I've got my green deployment and my default deployment. Now, the default deployment is the one that we're deploying right now, which is going to take a while. The green deployment doesn't work. So if I go into green, you can actually see here that I can browse the application, and I've built this with a little bit of a bug in my app. And I'm going to show you how to actually swap that over to be able to use microservices. So let's just wait for that to complete. There, it's completed. And I should be able to go now into my application, my default application there. Let's go find that URL. Actually, I can just go here and I can go to do. And I've got my Spring Demo Gateway services to do, and I can hit enter there, and it should actually, there we go. And the demo is deployed, and I did that live. And what this is doing is using to-do backend to get my to-dos in a nice way, and I can go buy milk. And there is a bug in here, which I have noticed, because it's reactive, the to-do backend doesn't like it. I can't actually delete it. We're going to try and fix that bug by doing a blue-green deployment. And this is actually using our gateway to isolate the services here. You can see their gateway, and we're not using the live URL. So I want to do a live blue-green deployment. Let's go to do. And all I have to do to swap it over, if I have a bug on my deployments, I just click on here, and I go set deployment. And then I'm going to go in, instead of green, I'm going to go to default and hit apply. And it's going to go roll that cluster for me, find the nodes, do all of that enterprise services for me. And this is really the demo that I wanted to show you. One is I showed you how to create cloud native Bullpecs, how to create a reactive to-do application. Then I pushed it to Kubernetes, and the demo gods weren't happy with my Kubernetes cluster, and it shows you how difficult Kubernetes really is to manage. And then I did the exact same with one command with Azure Spring Cloud, popped it over there, got my registry working, got my services ready, and let's carry on with the presentation. The final bit that I want to do with you, present to you. See how much time we also have, and we can take in some questions. You should be able to see my screen, and yeah, I'm good for time. So in this demo really was to create the to-do application. So we've got some great links that we can show to resources to help you getting started. First of all, you can use your Azure account right now to start with Azure Spring Cloud today and leverage the expertly maintained Microsoft Docs references. Then integrate with Azure Spring Starters into your projects to introduce Spring idiomatic Azure libraries. And finally, spend some time, quality time with our workshops to get detailed experience with Azure Spring Cloud. And take the survey that we have there, the QR code, We listen to your feedback, really, and you can access all of these. I'm going to leave this on here, and then I'm going to take your questions. So please, organizers, if you can give me some questions, and then I'll leave this on here and take your questions. Do we have any questions?
Yeah. Awesome, Rory. So going through the comment box, if there are any questions. So people are asking for the link to your code. So that we'll be sharing.
Yes, so all of the code, including how to start and also run more detailed microservices using distributed, is in the links that I'm sharing right now. So get started with Azure Spring Cloud. So you can go aka.ms/Spring Cloud Docs, and you'll get there first a Hello World application on how to get started using reactive microservices, and then also a more detailed one on how to actually create your gateway, your config, your distributed tracing, and all of that is via the links that I'm sharing right now.